In the last lesson, we learned about scope and return values and how to write clean, reliable functions. In this lesson, we are going to learn about modules and imports. So, what is a module? Think about it this way. When you are building a house, you do not manufacture every single thing yourself. You go to the market and buy ready-made materials like cement, iron rods, roofing sheets, etc. Other people have already made those things. You just bring them in and use them. You didn't create them from scratch. A module in Python works exactly the same way. A module is a file that contains ready-made Python code, functions, variables, and tools that other people have already written. Instead of writing everything from scratch, you import the module into your program and use what is already there. Python comes with a large collection of built-in modules that are ready to use. You do not need to install anything. They are already there waiting for you. In this lesson, we will learn how to import modules and how to explore some of the most useful ones. Let's open the terminal and go into our working directory. Let's create a new file for this lesson. Let's name it modules.py. The first module we will explore is called maths. It contains many mathematical functions. Let's type the following codes. Press escape, then let's save. Let's run it. You can see the results. Let me explain each one. Math.py give us the value of pi, which is 3.141592653589793. This is the mathematical constant pi that you know from geometry. Math.sqrt open bracket 25 close bracket gives us the square root of 25, which is 5.0. SQRT is short for square root. Math.ceil open bracket 4.3 close bracket gives us 5. CEIL is short for ceiling. It rounds a number up to the nearest whole number. So 4.3 becomes 5. Math.floor open bracket 4.9 close bracket gives us 4. Floor rounds a number down to the nearest whole number. So 4.9 becomes 4. You can see the difference between math.ceil and math.floor. Math.ceil rounds a number up, but math.floor rounds a number down. Notice the pattern we used: math.sqrt, math.ceil, math.floor. We write the module name that we imported at the top, followed by a dot, followed by the name of the function. This is how you use anything from the imported module. Now let's look at a shorter way to import. Instead of importing the entire module and writing math every time you want to use a function from it, you can import only the specific functions you need using the from keyword. Let's create another file named shortcutmodules.py. Let's write some codes there. Save the file. Then let's run it. You can see that it works the same way. But this time we did not need to write math dots before each one. We imported square root and pi directly, so we can use them by name. The difference is that when you use import math, it imports the entire module. It gives you access to all the functions, constants, and other tools available in that module. To use any of them, you must prefix them with math dots, such as math.sqrt or math.py. But using from math import sqrt, pi, this imports only the specific items you need. It allows you to use them directly as sqr and pi without writing math dot first. Both approaches work. In this course, we will mostly use the first method, which is import followed by the module name, because it makes it clear where each function is coming from. We won't be using the shorter way in this course, but you just need to know that it exists. Now let's explore the random module. The random module allows you to generate random numbers and make random selections. This is very useful for games, simulations, and testing. Let's create a new file called randommodules.py. Let's write the following codes there. Save it, then let's run it. You can see 3 random numbers between 1 and 10. Every time you run this file, you will get different numbers because they are randomly generated. Random.randint open bracket 1, 10 close bracket generates a random whole number between 1 and 10, including both 1 and 10. Let me run the file again to confirm that the numbers change. You can see different numbers this time. Now look at more things the random module can do. Let's update the file and explore more. Save it, then run it. You can see random.choice open bracket fruit close bracket picked a random fruit from the list. We did it twice and it picked different fruits each time. Random.shuffle open bracket fruits close bracket rearrange all the fruits in the list in a random order. Run the file again and see different results. You can see that the choices and the shuffle are different this time. Now let's explore the datetime module. The datetime module allows you to work with dates and times in Python. Let's create a new file called datetime-modules.py. Let's write the following codes there. Save it. Let's run it. You can see datetime.date.today open bracket close bracket gives us today's date, the year, month, and day. Datetime.now open bracket close bracket gives us the current date and time, including the hour, minute, second, and microsecond. We can then access individual parts like the year, month, day, hour, and minute using the dot notation. The datetime module is very useful in real-world programs. For example, if you are building an application that records when something was created or updated, you will use datetime to capture that information. Let's move forward. Let's explore the OS module. The OS module allows your Python program to interact with the operating system. Things like checking the current directory, listing files, and creating folders. You already know how to do these things in the Ubuntu terminal. The OS module lets you do the same thing from inside the Python program. Let's create a new file. Let's call it osmodules.py. Let's write the following codes there. Save. Then let's run it. You can see os.getCwd printed the current working directory, just like the pwd command in the terminal. GetCwd stands for Get Working Directory. The second one, os.listdir open bracket close bracket printed a list of all the files in the current directory, just like the ls command in the terminal. So the things you learned in the Ubuntu Terminal series are connected to what Python can do with the OS module. The commands are different, but the concepts are the same. Now, let's learn how to create your own module. A module is just a Python file. Any .py file you create can be imported into another Python file and used as a module. This is very powerful because it means you can organize your code across multiple files. Instead of putting everything in one long file, you can separate your functions into different files and import them where needed. Let me show you. First, let's create a new file that will serve as our module. Let's name it mytools.py. Let me write the following code there. Let's save the file and quit it. Now, let's create a second file that imports and uses this particular module. Let's name the new file use mytools.py. Then let's write the funny codes. Then save it. Run the file. You can see that it used all three functions from mytools.py successfully. Notice that we imported mytools, which is simply the name of the file without the .py extension. Python found mytools.py in the same directory and imported it. And notice that when I ran the file, I didn't run mytools.py. I ran the use mytools.py. This is how large Python programs are organized. Instead of one giant file with thousands of lines, the code is split across many files, each with a specific purpose, and they import from each other as needed. Now let's build a final practice program that brings everything together. Let's create a new file and let's name it luckynumber.py. Let's type the following codes there. Let's save. Then let's run it. Let me enter my name. You can see a personalized lucky number result with the name, today's date, and 5 random generated numbers. Let me run it again to show that the numbers are different every time. You can see completely different numbers this time. This program uses the random module to generate numbers, the datetime module to get today's date, and our own functions to organize the code cleanly. That is three different things working together in one program. Also notice something new in this program. The enumerate numbers, 1. This is a built-in Python function that gives you both the index and the value as you look through a list. The 1 means start counting from 1 instead of 0. So instead of printing number 0, it's printed number 1. You can use enumerate whenever you need a counter alongside your loop items. Let's push everything to the GitHub. Let's go and check GitHub. You can see that our new files have appeared in the repository.